Welcome to myprojectbazaar.com. Now we are going to discuss about our product title is Variation Tolerant Differential 80 SRAM cell phone Ultra Low Power Applications. Let me see our process abstract. A low power highly stable differential 80 SRAM cell. The impact of process parameters variations on various design metrics of process the presented in our compared with conventional differential for 60 to 80 process. The transmission gate based of 80 and single ended 80 process, and the impact of process variations like threshold voltage and length on differential design metrics of SRAM cells like read and write static noise margin, read access time and write access times are also presented. The process, the differential structure we have designed, why we are using the process, the sense margins is improved, so we using the differential structure, and then we going to show the larger reader current, shorter reader delay and better read stability. The low power 80, the process robustness to process the parameters and voltage variations. In our process 80 SRAM cells also higher read current to leakage current ratios. The leakage current power consumption is also less. The rest of the process organizes the structure of the operations and the SRAM cell structure, read, write and the whole mode of the described. The simulation of the process discussed, we using the low power and applications of variations of dynamic power decrease the first order leakage power length, and then low power on the supply voltage below the threshold voltage. The achieve main process low power SRAM cell, the differential structure at the same time using the higher read and lower leakage current process. In our process, using the low power 80 transistor stability of several SRAM cells proposed, which have some additional supportive peripheral circuits. We are using the classified the categories for single-ended SRAM cells and the differential SRAM cells. Let me see our process flow diagram. In our process, we have given the input for the input data for bitwise, and then we have designed the low power 80 SRAM design. The low power 80 SRAM design, the static random access memory are used as cache memory, which are embedding the microprocess, and we going to the system on chip and network on chip process. In our process, we have the compared with the RAM cells for and main memory access the process. The speed of memory has got the large increment. The gap between performing the capability of memory of the process, and we reducing the supply voltage and dynamic power decrease the first order leakage power decrease level, and the same time operating the cell in the sub threshold regions, the lower supply voltage below the threshold voltage. And we go into the read path operations for functions. The read operations is performed by pre-charging the bit lines, and then we go into the connect compared to the VDD and rising the WWL to VDD, the lowering process. The transistor of the turn on the 7th transistor the high, and the same time the node depending on the content of the storage node. The buffer transistor contact to discharge the transistor followed the by two path, one through the buffer transistor and the right bit of the process through pull down the transistor. In the case the same time the read bit line sensing the process, the pull down transistor main one of transistor going to the compared to the buffer transistor. The connectivity of the first buffer transistor and then fifth one of the right bit of the transistor, the discharge the main threshold value will be discharged. The same time the sensing of the potential difference between the bit line and bit line to bit for the continuously the amplifying the process to the read the operations. And we go into the right path functions. The write path functions during the write operations the raise the to VDD compared to the VDD. At the same time, complementary of the WWL now is pulled down because of the high of the WWL. So we decrease the level of the step by step. The both access transistor and the transistor of the 7 to 1 transistor is kept on. At the same time, initially storage the node for 1 and zeros. The logically we write to 1 and high. At the same time, low to high and high to low discharge through the fourth transistor of the voltage and node increase the towards VDD to time node. The L discharge of the process we go into the disconnecting the time, the final time of the discharge through ground to fourth one of the right bit of the data access. The we lastly we using that selection bit we using the right bit on the read bitting lines. Let me see our process running procedure. We have designed the low power 80 SRAM cell design in using the TAN ELA 13%. We have completed the designing. After we go into the simulation setup, we have using the three type of cells. So we have designing the each and every bit wise the continuously we how to we read and write the process. So first we simulate the process for going to the very important we have note the point for general. We select the transient and Fourier analysis. At the same time we should giving the rising and falling time. So use a setup for this one stop time for 200 nanoseconds and the maximum time set for 1 nanoseconds. Print start time. This also we completed kept on the process. After going to the very important for this one this like after we go into the very important for the library files. So in the library files which we have using the library the same time all the parameter values we using the library this type. The same time we choosing from library get the file library and this using type save for TT space like after we saving the process the libraries and we going to the running the process the we just start the simulation process. They automatically open the T space and we w edit waveform process the using waveform w edit waveform for viewing our simulation process itself for graphically. We got the output for the same read WL and then same the feedback controller and write bit lines and read bit lines. This same process we captured from here. We split the each and every line parameters value. So this is read WL and then this is the feedback lines what are we giving the 5 volt and then WWL write WL for the same time which port choose that bitwise. So this is a write bit line and this is the read bit line. We choose here this port we have read the process. So they will give the input for the 0s as 1s bit y here. This feedback write time for this time on we got the time for pulses. Another time is the fall off time, so we didn't get the output from here. So this process we just SRAM cells we are using the read and write the process. After using the which time using the process LT space the using the 0.91 second whole process running the time. Thank you watching our website.